The discovery of the electron is credited to J. Thomson, a British physicist, in 1897. At the time, there was growing evidence suggesting that atoms were not indivisible, as previously believed, but rather composed of smaller subatomic particles. The search for these particles was part of the broader understanding of electricity and the behavior of electric currents. Here's a brief overview of how J. Thomson made the discovery. Cathode Ray Tube Experiment. Thomson used a cathode ray tube, a vacuum-sealed glass tube with electrodes at both ends. When a high voltage was applied across the electrodes, a mysterious ray was observed traveling from the negative electrode, cathode, to the positive electrode, anode. These rays were called cathode rays. Behavior of cathode rays. Thomson investigated the behavior of cathode rays and found that they were deflected by electric and magnetic fields. The direction of the deflection indicated that these rays were composed of negatively charged particles. Determining charge to mass ratio, Thomson measured the deflection of cathode rays in both electric and magnetic fields and calculated the charge to mass ratio of the particles. He found that this ratio was much larger than that of any known atom. This suggested that the particles in the cathode rays were much lighter than atoms and had a negative charge. Plum pudding model. Based on his findings, Thomson proposed a new model of the atom, known as the plum pudding model. In this model, the atom was imagined as a positively charged pudding, with electrons, the negatively charged particles, embedded like plums within it. Naming the particle, Thomson referred to these particles as corpuscles initially. Later, they came to be known as electrons, a name that is still used to this day. The discovery of the electron was a pivotal moment in the understanding of atomic structure and laid the foundation for further research into subatomic particles and the development of modern physics. Later, the plum pudding model was replaced by the more accurate model proposed by Ernest Rutherford, in which a tiny, positively charged nucleus is orbited by negatively charged electrons. This paved the way for the development of quantum mechanics and the deeper exploration of the atom structure.